My name is Jiachen, and I work as a product manager at Microsoft. I've spent the past couple years on .NET, but nowadays I work on Azure Container Apps, specifically on the .NET developer experience, hence why I'm here giving this talk. I'm going to start off this talk by telling you a bit about microservices, and I'm sure all of you have heard plenty about microservices, so I'm going to focus not just on the good, but also the bad and the ugly. Then I'm going to show you how to use Donet Aspire and Azure Container Apps in order to fix some of these pitfalls or get around them. How many of you have heard of microservices before? Okay, like pretty much everyone. How many of you feel confident that you can explain what microservices are in like one sentence? Wow, like a half hand, brave man right there. Yeah, that's kind of what I expected. I've given this talk a couple times. Just total dead room, like everyone's pretending that they didn't just put their hands up. The thing is, microservices has become a bit of a buzzword, to put it lightly, right? At its core, it's a type of architecture where instead of having one piece, one monolithic piece, we are dividing it up into separate services, separate components. Now, there's a few terms that get thrown around all the time when we're talking microservices. So before I start throwing them at you, I figure it's probably polite to define them first. First up is Kubernetes. It is often used pretty synonymously with microservices when it's not. It's one way to do one specific part of microservices. Specifically, it is a tool for managing, deploying, and scaling all those little bits and pieces of microservices. As you can see above, even though it makes some things easier, it's still pretty complicated, right? Lots of moving pieces there. The other term you might have heard thrown around is containers. Containers are units of software. They contain all the dependencies you need, all the libraries, just all bundled up together. So let's say you want to move 500 lamps across the country. What do you think is easier? You take 500 lamps and you carry them all over, or you put them all into a shipping container and then you move that individual container. That's sort of the deal with containers in terms of software, right? You're not really worried about leaving behind a lamp or two in the rush of all the moving. Other benefits include they scale, they're portable, they're pretty secure because they're semi-isolated from its environment. And because of that, microservices are usually implemented using containers technology. There are 2 points I want to make about microservices. One is no one really knows what they are. It is a pretty vague term. You can see that I've pulled this excerpt from Wikipedia, which we all know is the source of all truth. And you can see that they say there is no single definition. A consensus has evolved over time in the industry. Now, that is a very diplomatic way of saying no one really knows. That people have a lot of different opinions, and over time, there's been some overlap, but there's also a lot outside of this overlap. So let me give you a specific example. The most ambiguous part of microservices is how exactly should these services be separated from each other for it to count as a microservice? And if you look closely, these defining characteristics of microservices, according to the single source of truth, they contradict each other, right? And I'm going to focus on the first one here, which says services are divided up by business capabilities, which I'm reading as functionality, what each service does. In other words, this separation is based on logical boundaries. So if you'll see up here to the right, this is my first time using a clicker with a laser and I'm just overdoing it. You can see that this system is split up based on what each part does. So we have the sales portion of it, and then we have the support portion of it. But the second one instead emphasizes that services need to be really small, and that they have to be independently deployed, and developed. In other words, this separation is instead about developmental and deployment-related boundaries, not really about the logical functionality. So the problem with that is developmental boundaries and deployable boundaries, they're actually not the same thing. So we end up with at least 3 different types of ways to divide up microservices, depending on your application, depending on what your team structure looks like, depending on even just how you are approaching software development. Some of these approaches might be terrible ideas. Some of them might be really, really good ones. And starting with the wrong approach can set you up for failure, even if your implementation is totally perfect, which with microservices, that's difficult to do to start. That brings me to my second point, which is microservices is a terrible name for what these actually are. The point of microservices isn't about having services that are small. I mean, who defines what small is when we're talking about code, right? They're also known as distributed applications, which make more logical sense, but unfortunately, they're not as catchy. So, I have 45 minutes here. I'm pretty sure saying distributed applications every single time is going to eat up like a good 30% of it. So even though I hate the term microservices, I'm still going to use it. Sorry, guys. But now that I've talked a bit about what microservices are, I want to bring you through the recent history of it a little bit. If you were at Richard Campbell's keynote the other day, you have seen this diagram. This is the Gartner hype cycle. Essentially, every bit of new technology will go through this particular journey where it kind of begins, it gets really, really hyped up, people realize, wait, this isn't what the hype promised, and then it just slam dunks into the trough of disillusionment, and it takes way longer to actually get to the point where this technology is actually useful and productive. Now, microservices are no exception to this. I mean, it's a term that was first coined either 2005, 2011. Different sources say different things, but a decade after that, microservices had become the answer to everything. There were case studies, there were research papers published about how essentially every company and every team needed to be doing microservices in order to keep up with the times. There were mentions of challenges, but they were very vague. They were like, don't worry about it. And instead, they focused on the benefits. They talked about high flexibility, high performance, high resilience. Now, how does the microservices approach result in those benefits? Well, because each service can scale independently, you can choose to scale up specific parts. So for example, if there's only one part that's a bottleneck, scale that one up. You don't have to scale up the whole thing. Changes can also be made to individual parts without affecting the other ones. And along with that, the idea is if one part goes down, the other parts should be able to hold up the load. So the question is, if microservices are so fantastic and there's so many benefits, then why isn't everyone using them? The headlines I showed before were all pulled from 2020, 2021, and I would say that was really the peak of the hype, right? Monoliths were the past and microservices were the future. Everything needed to be distributed. Migration was on everyone's minds, and just a few years later, that opinion has shifted dramatically. Amazon and Google had been huge advocates for the benefits of distributed architectures, but then Amazon Prime Video released this shocking expose about how moving back to a monolithic architecture actually saved them like 90% of their cost, or some crazy number like that. Around the same time, Google researchers they published a whole paper about how microservices essentially were not great and tend to backfire. So what happened, right? It's not like in 3 years, microservices just suddenly turned evil. Nothing had fundamentally changed about them. All the benefits that were raved about in 2020, they were still there, they didn't go away. Instead, developers began to realize what we discussed before, that microservices is a very vague, a very broad term, and just choosing to do it doesn't mean that you're going to get all the benefits, especially when you're not implementing it intentionally and in the right situations. They began to realize, oh, not everything has to be a microservice, and in a lot of cases, making something into a microservice actively hurts your project. It adds load. It forces engineers to learn things that they really didn't have to know. Long story short, developers realized they needed to define and implement microservices more intentionally. And specifically, they should be building them at their own pace instead of jumping into the deep end, learning everything up front, investing all the stuff, and then getting burned and just losing all of that. Even to give a concrete example, I've noticed at conferences I've been going to, there are just as many talks about how microservices are terrible or alternatives to microservices as there are about how to do them. Now, that was not the case a couple years ago, right? I mean, even look at this conference. Long story short, the conversation around microservices these days are much less black and white, much less monoliths, bad, microservices good. Teams began to lean into these shades of gray to figure out what exactly works for them instead of this 0 or 1 approach. They realized that when microservices were badly implemented, they turned into distributed monoliths that were tightly coupled. If one thing went down, everything else also went down. So it really offered the worst of both worlds, all the bad parts of monoliths, all the complexity and work of microservices. While really well-implemented monoliths, on the other hand, could become modular monoliths that kind of offered the best of both approaches. So those are just two examples of what emerged in these shades of gray between what had previously been a black and white conversation. For teams that want to access the benefits of microservices today, and there are many benefits, as I just talked about, even though it can be hard to remember when you're facing down a Kubernetes cluster, right? Because they really need to figure out if microservices are worth it for them. And in order to do that, they have to navigate up that slope of enlightenment and get to the plateau of productivity. Historically, though, that has been pretty difficult to navigate. You know, a lot of people just falling right off, especially for teams without existing knowledge of this technology. So let me give you a sense of what I'm talking about here. For someone starting off with microservices and Kubernetes and what have you, this is kind of what gets dropped on them right off the bat. This is like every single part of this microservices ecosystem with all your different options. The positive being you have a lot you can do. The problem is there is a lot you can do. You can think of it like a choose your own adventure where, okay, great, you can make your choices, you can go down different paths, but just like a choose your own adventure book, some of these paths will lead to terrible consequences, like death, dismemberment, and even worse, hundreds of wasted engineering hours. And it's pretty hard to tell what choices will lead to the bad endings unless you go through it yourself. And that's just because there is so much that can be done, so many choices that need to be made, so many ways in which you can make the wrong choices. So with that context, it's easier to understand why it has been so difficult for teams to navigate that slope upwards. So the question becomes, how can engineering teams do it more easily? That is where Donet Aspire comes into our discussion. Now, how many of you have heard of Donet Aspire before coming into this talk? Okay, like a good amount of you. All right, well, before I get into exactly what Aspire is and what it does, I mean, we have the marketing tagline, but I don't know how much you can actually get from that. Let's talk about the experience for .NET developers before Aspire became a thing. There were many new concepts that you had to learn about right away. You kind of had to become an expert in containers and microservices in order to get started with containers and microservices. You had to make decisions before you had the information to make them correctly. and there wasn't really much guidance about what is the right thing to do in order to build what you need. Now, I want to emphasize that it has always been possible to build microservices in .NET. The functionality was there, right? Hidden somewhere in here, the functionality was there. It just took a lot more time and experience and patience and DevOps knowledge than most software developers wanted to put in. There was documentation, a lot of it, but sometimes that just makes it harder to build something correctly. To put it in terms of the Gartner cycle, this was a very, very steep slope of enlightenment. What Aspire tries to do is build some stairs, and specifically stairs with handrails, so you do not plummet to your death if something goes wrong. I went on this rabbit hole trying to find a good definition of stairs. I don't know why it was so difficult, but the best one I found is that stairs bridge a large vertical distance by offering steps that consist of smaller vertical distances. Now, 3 benefits of that. Number 1, the distance becomes more accessible and climbable by different types of people with different amounts of physical ability. Now, if we're talking about the software world, that's more about different skill levels. It offers the ability to take breaks along the way, right? If you stop, you're not actively slipping back. You're able to just stop on a step and just go, okay, does this work for me? Am I just high enough right now that I don't need to put in that extra work to get all the way to the top? Last but not least, it is a clear path. If you're going down some stairs, up some stairs, there's kind of an obvious, next step that you're going to take, right? So Donet Aspire offers all of these things but for microservice development. Now, before I get into the conceptual benefits of Aspire, let me show you some code. Specifically, I'm going to show you how to get started with Aspire by adding it to an existing .NET application and get that running. I'm going to be starting with a pretty standard e-commerce website here. You can see that you get a decent UI, you get information that's being populated from this products database. And I recorded this demo because every single live demo I saw were just crippled by lag, so fingers crossed. So if we delve deeper into the code, there are essentially 3 parts to this. We have 2 services, a backend web API, it's called products. It pulls from, I believe, a SQLite database in order to get product information. Now, the way that data is stored is defined in the data entities folder. So that's not a service, that's just definitions of what the data structures look like here. And then we have a front end, which is written in Blazor, which is called store. Now, if I want to run this application without Aspire, I go into Visual Studio and I grab this thing called startup config because Visual Studio does not actually know how to run this. There's multiple potential applications to run to begin with. So I would need to tell it, okay, which ones to run, which ones not to run, which is a little annoying if you're dealing with 3 services, but can you imagine having 38? Like that's rough. So I'm going to add .NET Aspire to a project. Essentially all I do is I right-click, I go into .NET Aspire Orchestrator support, and I click Nice Buttons. As that's being done, I get 2 new folders that get generated. One is called App Host. Now, this is sort of the code version of what we had told Visual Studio to do. This is where we bring in all the different parts of our project, and we tell it how to connect to each other, and how to run different things, and in what order. So you can see that you can use C#, which is much more familiar than just clicking random buttons in the UI. Now, what I want to do now is set up service discovery. So what that means is I want to connect my services together. The back end needs to be able to talk to the front end. So you can see that this is a relatively intuitive process. I realize I'm falling behind a little bit, I'm sorry. But essentially what I just did was add a with reference, I added the friendly name, and now I don't even have to refer to a specific port. I just refer to the friendly name of products. I run that application, a dashboard pops up, which I'm going to talk more about later, but we can see that it's running successfully on our local machine. Let's go into the front end. We can display all the products that show up. And we can also just look into all this information that's being sent from different services within our application. As you just saw, there is a very clear path for getting started with .NET Aspire. If cloud development in .NET before was something like, here are 25 options to choose from, they are all great, they have their pros and their cons, .NET Aspire says, look, you're like trying to implement a web app. Those 24 options are just overkill for what you want to do. Just do this one, okay? And notice that the goal here is not to child-proof microservices development and block certain things off and tell developers what they should be doing. It's more the difference between having this huge pile of Lego blocks at your feet and being told, hey, build a 3-meter tall sculpture with great structural integrity. Like, it's hard to know where to start. With .NET Aspire, it's more like you got handed a Lego starter box set where there are instructions you can follow to get started, and nothing's stopping you from just getting more Legos and adding it on. The only difference is you can get to something that's working very quickly, very early on, with clear guidance. The concept of being opinionated shows up a lot across the different parts of .NET Aspire. But I want to focus now on the topic of integrations. So here is a list of nearly all, I think there's even more now, technologies that integrate out of the box with .NET Aspire. What Aspire says is, hey, here are some really great Lego pieces to use that can save you from reinventing the wheel or taking dependencies on technologies that are going to fail you at some point in time. And we're going to build in best practices around how to use these technologies in your application from the very beginning. At the same time, Aspire does not limit you. You will notice that AWS is represented here. And Microsoft loves Azure, as many of you know. This is what makes them money, but .NET is not just for Azure, and its integrations reflect that. And fun fact, the .NET Aspire team actually reached out to AWS to say, hey, Aspire is going to be a thing. Let's work together to build integrations. These integrations are mostly represented in this ecosystem of Aspire packages. Now, as you can see, this is just straight up NuGet Package Manager, but with an extra filter on it. This is nothing special. What is special are the packages themselves. They're pretty similar to the existing versions of these packages, you know, the non-Aspire ones, but there's two key differences here. One is that they have standardized configuration patterns built in so that you can have functionality that is important for microservices out of the box. So for example, if you want to know how your application is doing, you don't need to learn how to configure and add health checks and telemetry. It's built in. It's what makes the dashboard you just saw possible to start up without any extra work on our parts. Another benefit is that these integrations come in twos. You get one side that represents the service that you're connecting to, and then you get another package that represents the other side of the client or consumer of that service. So for each hosting package, there is a corresponding client package. So you don't have to build that bridge yourself. That brings me to the second benefit of .NET Aspire, which is it gives you the option to learn at your own pace, to learn as you go, instead of having to do a whole lot of learning upfront just to get the most basic prototype working. .NET Aspire handles a lot of these best practices that you need to have for microservices in order to make sure you're not building something that's going to explode in a couple days or weeks. But at the same time, it's not totally abstracted from you. All these configurations are being done in the form of code. You can go right in and you can change whatever you want. You can customize whenever you want. It's just that you get a template to start off with. Now, with this particular approach, applications become easier to use and to learn. And maybe just as importantly, they become harder to mess up. And as we just saw, that is very needed when it comes to the world of microservices, especially when you're trying to climb that slope of enlightenment and not fall off. It's a great way to get things working from the start and figure out early on whether microservices is actually the right approach for your team, instead of having to commit so much time, so much energy and effort in order to get to the point of saying, okay, that's actually terrible, like a monolith is better. It helps you avoid the sunk cost fallacy of, I put the time in, now I'm locked in, I have to do it to the end. As I mentioned, the Aspire dashboard is a great example of what you can get from day one without having to do any work yourself. Now, the dashboard does a lot. I'm not going to spend the next 15 minutes running you through each capability, but you can see logs, you can see traces, you can figure out the environment configurations, and you can get all that information in real time. You can also stop, start, and restart resources directly from the dashboard. Now, that's a great way to identify issues early on in your development cycle. That makes it very helpful to solving some key issues with microservices, which is around the architecture design. You can validate how well something is working or how terribly something is working pretty early on, because you can see how these services are communicating to each other and identify inefficiencies fast. All this functionality of the dashboard comes from OpenTelemetry. All that gets set up for you under the hood. And Aspire also handles, oh gosh, there's like a big list, but essentially resource service endpoints, authentication, telemetry limits, a whole lot of other things. And again, all of this is customizable. You can even use this dashboard with partially .NET applications. You know, with microservices, a lot of them can be built in different languages. You can even grab this as a Docker container and use it for a non-.NET application. Kind of cool. So let me show you a concrete example of how the Aspire dashboard can help you identify inefficiencies and cut them down. In the eShop application I just showed you, 7 things have to happen for the user to see what items are in their shopping cart. I have this on the board. I'm not going to force you guys to listen to me read through all of them. My point is, you can configure and resource every service perfectly, but you're still dealing with inefficiencies just because communication has to happen across so many different pieces. So what I'm going to do here is tighten that loop. And what I'm going to do is use a Redis cache so that instead of having to call from the database every single time, after the initial call, I store that information for a set amount of time so that I can retrieve from there instead of making the full journey. Let's take a look. Our first step here is to add the Redis package for a project. So as you recall earlier, there's going to be 2 Redis packages that we're working with. Right now, we're working with the one that represents the client or the consumer of the Redis service that's in action. So we added over to app host, which again, that's where everything is being controlled, right? So we defined this Redis resource, and I'm going to come up with a very creative name for this. It is Redis. And it is a pretty intuitive line of code in order to do that, right? Builder.addRedis, and that's my friendly name. Hooray. I want to reference Redis within my front-end store, and I do that by writing with reference Redis. This is pretty readable going through. You can get a general sense of the architecture of this application. So now I'm going to go to the front-end store, and I will find the corresponding Redis package, which is Redis output caching. So I install that. And in order to use that in my front end, I'm repeating the whole it's like pretty intuitive, but like you add Redis output cache and you reference that same friendly name that we've been using earlier on. I feel like these lines of code I don't even need to explain. It's kind of exactly what it says on the can. But now what I want to do is I go into the Razor file where I'm defining the actual web page, and I tell it to use Redis output cache and pass it a parameter of 10 seconds. What that does is define the amount of time in between each refresh of the Redis cache. So specifically, every 10 seconds, it grabs something from the database. If a person refreshes before the 10 seconds is passes, then they get the same information from before. So I'm running this now. You can see that there's a Redis instance now. It's in a container, nothing that we had to do personally. We just had to add the package. So you can see that the first time around, we're getting it from the product's backend. So that's like the full journey that you make. Now we refresh, and you can see that we no longer have to get that data from products. It's coming directly from the cache instead. So as you can see, after that initial call from the database, to the database, our loop can be a lot tighter and a lot more efficient than before. Now this is something that you can just keep on doing with the dashboard because again, it's live information. And it's pretty low effort to tweak different things, just trial and error, see what happens. Everything I've shown you so far culminates in this last benefit of Donet Aspire, which is it allows software developers to focus on what they want to build instead of the technicalities of how they should be building it, of figuring out what the heck are containers, how do I containerize my applications, how do I write these manifests and these deployment files. It's just, what do you want to build? Okay, we're going to help you with the rest. Now, Donet Aspire is really focused on the local development experience for microservices. But just as important, if not more important, is the deployment and the hosting of these microservices. I mean, that's what Kubernetes is all about, right? The good news is there is a streamlined path from local development with Aspire to deployment with the Azure Developer CLI, as you see here, AZD, and then to the Azure Container Apps platform. So I'm going to spend the rest of my talk zooming into those two pieces. I'm going to really quickly check on time for 30 minutes, 15, cool. Now, there's a pretty smooth deployment experience that might also potentially be too terrifying because it is too smooth. This is offered by AZD. Essentially, with 2 commands, you can deploy everything to Azure. Now, you do AZD init, AZD up, it's all out there. It's cool, it's magic, it's scary. We don't know how everything's working under the hood. But the good news is, again, that whole idea of, yes, we're going to abstract it, but we're not going to block it from you forever. If you want to see the files that were generated by these commands, so the bicep, the YAML, it's all the files that you're already used to working with, you can run a command called azd infra-synth. That shows you everything. You can take those files, plug them into your own deployment pipelines, customize them to your needs, what have you. All this does is it gives you a template to start off with. Now, I'm going to talk a little bit now on the default hosting platform for .NET Aspire applications. Again, I want to emphasize this is not the only option. There are a gazillion out there, but in my opinion, at least, this is the easiest. And again, because it is the default, there's more tooling built in to make that integration smoother. It also, I think it best embodies that philosophy, the philosophy of focus on what you want to make happen, not the details of how you want to implement it. Container Apps is essentially an abstraction built directly on Azure Kubernetes service. So it's not just like Kubernetes, it's just straight up like Kubernetes with more usability built in. Essentially, it's a way to use Kubernetes without having to think about and to learn and to manage all the infrastructure associated with it. I could spend like 48 hours talking you through the details of how Kubernetes works, but I just, 30-second version. You get a cluster of nodes. Nodes have containers as well as pods. Now what pods contain is everything you need to run your actual code. And once you get in there, then we're talking kubelets, we're talking container runtimes, kube proxies. I think Kubernetes just kind of They take real words and then they add cube in the front, and then that's their approach. With container apps, instead, you're working with container app environments, which are basically clusters, like one environment maps directly to one Kubernetes cluster underneath. Then you have the individual container apps inside. Now, I know it says revision, replica. Those are not actually part of the structure. Revisions are like different versions you make over time, and replicas are like when you scale up and down, the new instances that get created. My point is, with container apps, you're thinking about how the application is broken up, but you're not thinking as much around what's needed to make these different parts of the application work with each other. That gets handled for you. Now, as you can tell, they have very similar structures, and I'll go more into detail later, but there are limitations to container apps, right? With any sort of abstraction, you lose a bit of granular control. But once you hit the point where you have to move to Kubernetes outright, you're already used to this particular mental model of thinking around microservices. So you have the tools to easily migrate over. Another piece here is Aspire maps pretty intuitively to container apps. You can see that one solution becomes one environment, and each project within it then becomes an individual container app. So just really quickly running you through some small features that are good to have within container apps. We have the Aspire dashboard still available on the platform itself. So even after you've deployed this application to production, you can still see that live data coming in. You know, it's not like once you leave local development, like it's over for you, you don't get to see anything about your application. There's something called single revision mode. You might remember revisions are like different versions of a container app. The idea here is as you roll out different versions, traffic gets switched over automatically. It's not like you roll something out and you have to worry that customers or users don't have access to the previous version anymore. It just swaps over. Last but not least, save money, scale to zero. The base idea is if you're not using something, then you don't get charged for it. Cool. I want to end on this kind of brutal honesty piece, which is, of course, not everything is a great fit for Azure Container Apps. And there's a sort of like too little, too big situation where if you don't need all that extra infrastructure, then you might as well just go for Azure App Service or even Azure Container Instances. Now, it's confusing because it's Azure Container Instances, Azure Container Apps. I mean, I'm not in charge of the naming. Fortunately, unfortunately, that's above my pay grade. But those are more about singles. Like if you don't need scaling, if you're just dealing with a single container, that's all you need. Now, last but not least is if you're getting to the point where you need access to that Kubernetes control plane, where you need that granular debugging, then okay, go over to Azure Kubernetes Service. Been talking a whole lot. I'm going to do a quick review here. So we talked a bit about why microservices are so difficult, and specifically why it's difficult to get them productive. Then we talked a bit about how .NET Aspire helps, what tooling, what features, what libraries it offers to help people up the slope of enlightenment, regardless of their skill levels. Last but not least, I talk a bit about Azure Container Apps and how it and AZD extends the Aspire experience beyond local development and onto the long-term hosting running of your applications. That brings me to the end of my talk. Thank you all for coming. I can be reached on, I didn't update this. I'm actually off of X right now. I'm on Blue Sky. It's just my name without the underscore because I got there early enough that no other Jiachen Jiangs beat me to the punch. I also have stickers for, unfortunately, just Azure Container Apps specifically. Microsoft really tightened their budgets. All I got is stickers, but I'm happy to offer what I've got. So thank you everyone for coming. I hope you enjoy the rest of your conference, and thanks for having me.